Good day, students. Welcome to mathgotserved.com. In this clip, we're going to be going over how to find limits involving indeterminate forms. We're going to look at how to find limits of indeterminate forms using algebraic manipulation, L'Hopital's rule, and also the limits definition of a derivative. To get us started, let's take a look at the possible results you can get when evaluating limits, finite algebraic limits algebraically, okay? So, possible results when evaluating finite limits algebraically. Alright, so these are the possible results you can get. You can get a number, a defined number as an answer. You could get positive or negative infinity. You can also get an undefined result. Okay, you can get an undefined result in two cases. You can get an undefined result when you have a non-zero number divided by 0. This is undefined. Or in some cases you can have an oscillation. Okay, when it's oscillating, then that limit does not exist also. It's not defined. And then lastly, which is what we're going to be focusing on today, is you could get an indeterminate form. Okay, indeterminate form. Now, what is an indeterminate form of a limit? Well, there are multiple forms, multiple indeterminate forms, but in this presentation, we're just going to be focusing on the form 0 divided by 0. Okay? Now, you want to know the difference between undefined and indeterminate. Undefined requires the numerator to not be 0 and the denominator be 0. But the indeterminate form we're looking at today involves the numerator and the denominator to both have the values of 0 when you evaluate the limit by substitution. Now, if you have an indeterminate form, how do you evaluate the limit? Well, we're going to be looking at three methods in today's presentation. The first method you could use is algebraic manipulation. Okay, it could be trigonometric manipulation too, so algebraic / trig manipulation. So you just basically rewrite it, use whatever properties of equality that you want to use or trig identities, and see if you can carry out a cancellation that removes the removable discontinuity causing the indeterminate form. You can also use L'Hopital's rule. This is always applicable to limits of indeterminate form. And lastly, this is a special scenario where you can apply the limit definition of a derivative. You cannot, this doesn't always work, just like the first one. There has to be a problem of a particular format. So limit definition of a derivative are basically limits of the form limit as h approaches 0 of f of x plus h minus f of x over h. So something like this is a limit definition of a derivative. Or you can have limit as x approaches a of f of x minus f of a divided by x minus a. Okay, so if a limit is presented in this one of these two formats, the limit definition of a derivative will be applicable here. Okay, so the example we're going to be looking at today will be a situation where all these three methods work, so you can see all of them in action. Alright, so let's go ahead and take a look at an example. Now the task is to evaluate the given limit. So we want to evaluate the limit as h approaches 0 of 2 plus h quantity cubed minus 2 cubed divided by h. Okay? Alright, let's go ahead and do it. Now, whenever you are finding finite limits algebraically, you know what the first step is, right? So let's go ahead and write down what the first step is. You can recall Sally. Alright, so the first step is the S step, which is to substitute. Okay, so you're just going to substitute what h is approaching into the h values. If we carry out the substitution here, so let's put it in the next line. I'm going to substitute following the Sally algorithm, and then we're going to have, this is going to become 2 plus 0 raised to the third power minus 2 to the third power divided by 0. Okay, so we just plugged in, substituted 0 for h because that's what h is approaching in this limit. Alright, and let's go ahead and simplify completely. Do not be in a haste to conclude that it's undefined if you have a denominator of 0, because the numerator could also be 0, which will mean it's indeterminate and not undefined. Okay? Alright, so 2 plus 0 is 2, so we have 2 to the third power minus 2 to the third power divided by 0. 2 to the third minus 2 to the third is 0. 0 by 0. Ladies and gentlemen, we have an indeterminate form. Okay? So whenever you have an indeterminate form, we are going to use ALL. Okay, those are the three methods that we can use. We talked about that previously. So if you look here, we have ALL. ALL, either use algebraic manipulation, L'Hopital's rule, or the limit definition of a derivative. Okay, so you can use just one if you were taking a test, for example, but in this presentation I will show you how to use all three, and then you can pick whichever method you feel most comfortable with. Alright, a lot of times, as you will see, the limit definition method is the fastest, but it's not applicable to all scenarios like L'Hopital's rule or algebraic manipulation. So that's the limitation of that fast approach. Okay, so now we have an indeterminate form. We're going to go ahead and try the three different methods to find limits of indeterminate form. So method 1, we're going to use algebraic manipulation. We don't need trig here because there are no trigonometric identities involved. Some problems involve trig identities, and you have to make use of that in the process. So we have to evaluate the limit as h approaches 0 of 2 plus h to the third power minus 2 to the third divided by h. Okay, so we see this binomial that's been raised to the third power. We need to expand it. Okay, we need to expand 2 plus h to the third. So we can just FOIL it 3 times, or we can use Pascal's triangle. So we're going to use Pascal's triangle here. So if you remember what Pascal's triangle is, we have 1, 1, 1. So this is row 0, this is row 1. Row 2 is 1, 2, 1. And then row 3 is 1, 3, 3, 1. Alright, so you just add to two numbers on the top to get the bottom middle. Alright, so this is the row that we're going to be extracting. Alright, so this is part of the coefficient of the terms. So we're going to have, just take these numbers, this horizontal row right here, and align it vertically. 1, 3, 3, 1. Okay, and then we take the first term times 2 times 2 times 2 times 2. And then the next term is positive h, so times h times h times h times h. Okay, so the 2 will descend from the power 3 all the way to 0. So we have 3, 2, 1, 0. And then h will ascend from 0 to 1. So h to the 0, 1, 2, 3. Okay, so let's multiply the terms out. That will give us the terms of the expanded form of the binomial cube 2 plus h raised to the third power. Alright, so we know what happens when you raise a number to 0. It becomes 1, so this is going to be 1 right here. And this 2 to the 0th power will be 1 also, so we don't have to waste our time with that. Okay, upon expanding, 2 to the third power times 1 is 8. 2 to the second power is 4 times 3, which is 12, 12h. And then 2 times 3 is 6, 6h square. And then lastly, we have h to the third power. Okay, so all this work helps us to see that when we expand 2 plus h to the third, we're going to get 8 plus 12h plus 6h squared plus h to the third power. Alrighty? Now how does this help us? Well, we're evaluating the limit. Let's rewrite the question as h approaches 0 of 2 plus h raised to the third power minus 2 to the third. So we are now going to take this expanded form we just found here, and we're going to take it and we're going to sub it into this spot right here. Replace the entire expression with what we just found. Okay, so the limit is going to now become the limit as h approaches 0 of 8 plus 12h plus 6h squared plus h to the third. So we have now replaced 2 plus h to the third, and then we have minus 2 to the third, which is just 8, and then we divide that by h. Okay, divide that by h. Alright, so let's see what happens. You notice that the 8 and the minus 8, we can subtract those. That's subtracted out, and we are left with limit as, it's too thick, let's make it thinner. Limit as h approaches 0. Now another thing you'll notice is that h is common in these three terms, so we can factor that out. To factor out the h times 12 plus 6h plus h squared. Alright, that divided by h. And then we can divide that h that we factored out with the h in the denominator. Bam, bam. So that removes the removable discontinuity that's causing our limits to be indeterminate. So now we should be able to evaluate the limit without any problems. Alright, because that annoying denominator component has been taken care of. So we have the limit as h approaches 0 of 12 plus 6h plus h squared. All we have just done is algebraic manipulation. We just expanded and can't reduce. That's all we did. Now we can substitute again. If we carry out our substitution, we're going to have 12 plus 6 times 0 plus 0 squared. And then this is 0, that is 0. Our final answer is 12. Alright, so this is one way you can find limits of indeterminate form. Just use your algebraic manipulation, cancel, reduce, and then you should be able to find a limit. Alright, let's take a look at another method of finding the limit. We're going to be using L'Hopital's rule, which is basically the most powerful method here because there is barely any restrictions on it, and it can be extended to limits involving infinity also. Okay. Alright, so L'Hopital's rule is method 2. Alright, L'Hopital is named after a mathematician. His name is L'Hopital, so as you might have guessed. Alright, so what's L'Hopital's rule? First of all, let's write down what the formula is. The formula for L'Hopital's rule is as follows. If you're finding the limit of a quotient, so let's say limit as x is approaching a number of f of x over g of x, it's the same thing as finding and you have an indeterminate form, it's the same thing as finding the limit as x approaches a of the derivative of the numerator divided by the derivative of the denominator. Okay, so we are not applying the quotient rule here. That's totally different. In this particular scenario, we're differentiating the top and the bottom independently and then reevaluating the limit of their derivatives. Okay, so let's apply that idea to this problem. So we were originally looking for the limit as h approaches 0 of 2 plus h to the third power minus 2 to the third, that divided by what? Divided by h. So if we apply L'Hopital's rule, since this was indeterminate, we're going to apply L'Hopital's rule, and what we're going to do now is basically differentiate the numerator separately and then differentiate the denominator and then evaluate the limit again. Alright, applying the properties of limit, this could be broken down using the sum and difference rule into the limit as h approaches 0 of 2 plus h to the third prime, so the derivative of this right here, minus the derivative of 2 to the third, and then divided by, go ahead and differentiate the denominator separately. We're differentiating with respect to h in this problem, okay, over the derivative of the denominator. Alrighty, now if you take a look at 2 plus h to the third, this is a composite function. It is a composition of a linear function and a cubic function. The inner one is a linear function. So anytime you're differentiating composite functions, you always want to use the chain rule. Okay, so let's go ahead and do that. So we're going to just focus our attention on this piece right here because it's complicated. The other two components are easy to differentiate. So we extract that piece, let's call it y. Y equals 2 plus h raised to the third power. Alright, and what we're going to use now is what we learned in the previous lessons, the chain rule. Right, the chain rule just basically means that you're differentiating the outer evaluated at the inner times the derivative of the inner. Alright, so let's make it more visual. We're going to decompose the function y, this composite function right here. So what we're looking for is we want to find y prime. Okay, so we want to find this prime right here. We want to find y prime, which is this entire thing prime. Let's just rewrite it so it's not confusing. Y prime is going to be 2 plus h to the third prime. Okay, so we'll take the outer function and we're going to call that f. Okay, so f of h is the outer function. The outer function is the cubic function. And then the inner function, we're going to call that g. Alright, so g of h is 2 plus h. Now we're going to differentiate both. So differentiate the outer function, which is 3h squared, and then differentiate the inner function, which is the derivative of 2 is 0 and the derivative of h is 1 with respect to h. Alright, so the chain rules as follows. You differentiate the outer function and evaluate it at the inner. So what we're going to do is take the inner function and plug it into the outer function and then multiply our answer by the derivative of the inner function. Alright, so y prime, the derivative of the first term, this composite function, is going to be 3 times 2 plus h square. Okay, I replaced 2 plus h with the h, so square, times the derivative of the inner function, which is 1. Okay, so y prime is 3 times 2 plus h squared. Alright, let's rewrite the problem again and then apply this answer that we just got. So what we're doing is we were applying L'Hopital's rule. Okay, L'Hopital's rule was a limit. The limit as h approaches 0 of the derivative of the top, so of 2 plus h to the third prime, right, minus the derivative of 2 to the third divided by the derivative of the denominator. Okay, so what we just did is we found the derivative of this component right here, which is 3 times 2 quantity 2 plus h squared. So what we're going to do is we're going to, in the next line, take the derivative that we found, this derivative right here, and we're going to plug it in. It's going to take this spot right here. Okay? Alright, let's go ahead and put it in. We're going to have 3 times the quantity 2 plus h. Oh, let's not forget the limit. Limit as h approaches 0. 3 times the quantity 2 plus h minus the derivative of 2 to the third is the derivative of a constant, which is just 0. Okay? Using our constant rule for differentiation, divide that by the derivative of h with respect to h is just 1. Alright, so this essentially becomes the limit. Oh, let's not forget the square here. Sorry about that. So there's a square. Okay, so limit as h approaches 0 of 3 times quantity 2 plus h squared. So now we can now evaluate the limit again by substituting. Okay, so remember L'Hopital's rule just says you can differentiate and then evaluate the limit again when you have indeterminate forms. Okay, so what we're going to do is just plug in 0 for h, and that will give us 3 times 2 plus 0 square, which is equal to 3 times 2 square, and 3 times 2 square is 12. Alright, so this is L'Hopital's rule. It's pretty much the most powerful rule here when finding limits of indeterminate forms. Alright, let's take a look at the last method, method number 3, which is the limit definition of a derivative method. Okay, so let's go ahead and write it down. So we have method 3, which is the limit definition of a derivative. Now this is a specialized method, okay? You can only use it if the problem presented is in a particular format. What format? Is in the format of the limit definition of a derivative, okay? So what are we talking about? Let's go ahead and write down the forms that enables you to make use of this special method right here, which is extremely cool. So the forms or the formulas of a derivative, the limit definition of a derivative at a point is limit as h approaches 0 of f of a plus h minus f of a divided by h. Now this right here is simply the derivative of the function f evaluated at a. Okay? Or if you have the limit as x approaches a of f of x minus f of a divided by x minus a, this is also f prime of a. So there are two limit definitions of a derivative. Okay? So in this particular problem, what do we have? Let's write it down. We're looking for the limit as h approaches 0 of f of 2 plus h to the third minus h minus 2 to the third. Alright, this entire thing divided by h. Now the question is this problem that we're dealing with right here, is it consistent with any of these two forms? The answer is absolutely. It is like the first form right here. Okay? So let's go ahead and write in a quick remark, which is that this problem that we have is of the form limit as h approaches 0 of f of a plus h minus f of a divided by h is of this form. So in essence, what we're simply looking for is f prime of a. So all we have to do in a problem like this is rewrite the problem, and then we can just use the derivative to finish it off without any problems. All right. So step one is to rewrite the problem. All right. So if we want to rewrite it, we want to rewrite it as the derivative at a point. So we need to know what a and f of a is and what is f of x. So let's go ahead and do that. In this particular formula, you can see that a is what is being added to h. So what does that tell us? It tells us that a is 2 because that's what's being added to h in this problem. Okay? So that's the trick right there. A is 2. So for the rewrite, we know that a is 2. So if a is 2, then f of a is going to be what? If a is 2, then f of a is this part right here. F of a is 2 to the third. Does that make sense? F of a is 2 to the third. So now, can we guess what f of x is? If f of a, which is this portion right here, is 2 to the third, then what is f of x? You just simply replace a with x, right? So f of x is going to be x to the third power. And there you have it. Okay, so to rewrite this problem, the problem is going to be to do what? The problem is going to be to find f prime of 2. Find f prime of 2 where the function is x to the third. Now the beauty of this process is just by inspection you can mentally compute what this limit is, because you're not differentiating a difficult function. If you differentiate this function, you get 3x squared, you plug in 2, you're done. Okay? Alright, let's go ahead and show the work on how to evaluate this limit using the limit definition method. So when you're looking for a derivative at a point, you have to remember that there are two steps involved. Alright? So we're looking for f prime of 2. So first thing we want to do is we want to find the derivative. So you do your calculus first before you do your algebra, okay? So you find f prime of x, differentiate first, and then you can evaluate. Do not switch the orders or try to do them simultaneously, because you end up with the wrong answer. Alright, and evaluate f prime of 2. Okay, so let's go ahead and do it. We're going to find the derivative first and then evaluate after. Okay, so step 1, we know that f of x is x to the third. So that automatically tells us that f prime of x, using the power rule, is 3x squared. Okay, and then f prime of 2, we're now going to evaluate, is going to be 3 times 2 squared. And then 3 times 2 squared is just simply 12. And that, ladies and gentlemen, is your final answer. Okay? So whenever you're given a limit, an indeterminate limit that's in the form of a limit definition, I would strongly suggest to just use this method right here, because all you need to do is identify f of x and a, and you could do it in seconds. The other methods could be really complicated depending on the nature of the problem. Okay, so this is basically how you find limits of indeterminate forms using algebraic manipulation, L'Hopital's rule, and limit definition of a derivative. Alright, so how well did you master the contents of this presentation? To demonstrate mastery, we'd like you to try out the following problems. So try these out. So the task is as follows. We'd like you to evaluate the limit the given limits using the three methods presented or discussed. Okay, so the three methods we discussed earlier, we'd like you to use it to find the limit of the following. So first one is find the limit as h approaches 0 of 3 plus h cubed minus 3 to the third over h. And then the second one is the limit as h approaches 0 of the square root of 5 plus h minus the square root of 5 over h. Okay, so go ahead and pause this video presentation. I'll try out these two problems. When you're done, you can click back on play to see what the answer is. Alright, let's take a look at what the answers are. I'm just going to use the third method for these three real quick. So for number one, you have to find, when you do the rewrite, find f prime of x, where, find f prime of 3. Find f prime of 3 where f of x is x to the third. Okay, so if f of x is x to the third, f prime of x is 3x squared, and f prime of 3 is going to be 3 times 3 squared, which is 27. And then for this one, you have to find f prime of 5, where f of x, the function, is the square root function. If f of x is root x, then f prime of x is going to be 1 over the 2 root x, and then f prime of 5 is going to be 1 over 2 root 5, and then you can rationalize that, times the top and bottom by root 5, and you have root 5 over 10. Okay, so there you have it. Thanks so much for taking the time to watch this presentation. Let us know what you think. If you found the contents of this tutorial helpful in your studies of limits and the indeterminate form of it, go ahead and give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the problem we solved or the additional problems, do post it in the comment section below, and we'll be more than glad to respond. Don't forget to subscribe to our channel for updates to other tutorials such as this. More support resources and tools can be found at mathgotserved.com. Do check it out. Thanks again for watching and have a wonderful day. Goodbye.